What's up, YouTube? Going to do a little upgrade conversion on my Voron here. I finally started to have some issues with my original Klicky probe that I installed at day one of the build. I'll do a screen share here, but I made a list of my Z calibration using Auto Z, and I started to notice quite a bit of deviation in the first layer, and then the nozzle was like ramming into my nozzle brush, and you can see, let me switch here. Alright, so I was saving the Auto Z values to see where the discrepancy was, and we can see my end stop pin is the same every time, and then my nozzle was just barely different, which I presumed was just a little bit of probably filament on the tip there. But then if you look at my switch, so this is when it was probing the body on the Z end stop. The deviation here was quite different. So I got to looking at everything. I couldn't quite find anything wrong. I pulled the probe off. Checked this guy. I made sure those were tight. Everything. Checked the switch. Made sure it was in the bracket tight. Everything was good. So couldn't figure it out. So then I preemptively ordered Klicky probe kit because I wasn't really sold on tap, at least not yet, because there's some stuff still kind of breaking for a lot of people, it seems like. But I ended up turning off Auto Z calibration and did virtual end stop, which resolved a ton of my issues. And then one day, shortly after, it stopped printing again, and then this was it kept getting an error when I went to start a print. So this was on the tool head here, but this magnet had came out and it was like stuck to the bottom, so like it wasn't docking right and it wasn't reading right. So one of these came loose, which was sort of surprising because I was perfectly fine the entire time, but I guess that's why a lot of people decided to switch away from this version. But when I built this, there were some variations in the magnets between 3 mil and like 2.7, and that I think was part of an issue when I did initial assembly. But the way these parts were printed, which I got from somebody, I had to really use some heavy duty pliers and squeeze these in here, just because the fit was that tight. But I used crazy glue gel and a liberal amount on that. So I glued it back in so I was able to do some more prints shortly so I could print my extra parts. So we have this is what I needed to print over for this new Klicky PCB. So this is going to be the top piece. And you can check out the GitHub. And then there's like these magnets, flat magnets with recessed screws, a JST connector, which you'll run up to your probe. This is going to go after you put heat certs in it. It's going to go on here, and that'll be our new piece. And you put a screw in here. And this is going to end up docking into there. And this one is going to mount to this one with that plug. So that's going to go in there like that. And then they're going to, this is a backup one, but then they're going to magnet together with recessed magnets with screws, so there's no glue. You can run this Klicky probe in a 24 volt setting or a 5 volt setting. And I'm not sure which one's better, but I think I'm just going to go with the 5 volt, which means I need to put this solder blob on here because those pins need to be bridged for the correct current. It says right here. And then make my little short harness here to connect to the new microfit on the tool head. And then just have to make very little tweaks because this is in a slight offset compared to the original Klicky. So you can see, like this one is out in the front, but you can see that switch is to the left more than that one's kind of centered. So there's just very little tweaks there with the Klicky macros that you got to do. They do recommend using this latest dock version, which is the only spot that I'll get glue or whatever choice you wish to use. But this comes in the kit. You just have to print the parts. Some places sell it with the printed parts, but you get the extra backup probe. You can use the original style probes like this D2F, or whichever it is, as opposed to this style. It says Omron on it. No idea if it's genuine or not. But you get 2 of those, 1 of these, and it's probably a good idea to have some spares on hand because the simplicity of this board here, basically you just desolder that and then you put a new switch on there, no problem. But in hopes, I printed these parts kind of thick to increase rigidity. So in theory, the only chance of an issue I should have now would be this dock magnet. But I'm going to get to working on taking this apart, getting this mounted and wired in, and then I'll give you an update. Alright, I've got 3 strips of wire here for the wiring. I'm going to do that last. We're going to go ahead and get these inserts put in, hopefully without ruining it. Waiting for this to heat up. So they gave me 10 of these, it looks like, which I guess you really only need 6. So you got 3 per each one. And more than likely, if you're going to switch, you can just unscrew it and put it on this one, or just print actually 2 of the lower mounts, I guess, which would be faster for swapping. So maybe I'll print another one. But you want that edge, the kind of skinnier edge, to go down. I'm going to freehand it. Just want to make sure you go in pretty straight and that it's flush. then we need you take that guy. Doesn't show it on the GitHub, but I'm pretty sure this is what they want. This is going to go on the back of this, so when it docks, that connects to the magnet. So it should be tight enough fit to where it can't come loose. They say screw it flush, but you can't get it 100% flush without, it'll just strip it out, the plastic. So just snug it up. It says use the app for the magnets for these special ones that come with the kit. You can determine polarity, and it tells you on the GitHub page which ones to put where. So you'll see that side is conical recessed. That side is flat. That's for the so this is going to go like this. And then we just need to determine the correct magnets here and then put the screw in to hold this onto this bottom PCB. Alright, something I noticed here talks about magnet polarity and using your phone with an app. I wasn't having good success. It kind of gave me both readings on a lot of magnets. So I ended up just putting 3 on there. And then don't use the flat side because the flat side's got to go up. So use the screw side. So screw the screw side, and I just tested them till I got 3 that went on. So I had to go through a few. So like those two are on there. And this one, see how it flipped because the polarity is wrong. So I just went through a few until I got it to work. But that one, polarity is right. Okay, we got those loosely fitted. Everything's good there. So something I noticed, there's almost no wiggle room in the PCB fitment there. But when you go to tighten these, you can almost move the magnet. So I would just try to get the magnet with the best coverage on the pad there of the PCB. Not that it probably matters, but why not? Okay, so I need to print another adapter if I want to do that one with the extra parts there. And then I just need to crimp some wires, and so it comes with my 3 pins. It tells you the orientation in the GitHub there. Alright, YouTube. So I was trying to do the solder on here for the 5V, and it's just 2 solder pads. Well, I was having difficulty getting a good solder I'd end up with it on each pad, but not together very well. So I don't know if you didn't need a different technique. So basically, I just sucked off what was there, and I'm going to run it 24 volts. So I got that. I got my magnet in the mount. Just need to mount this back on. Finish the wires, and then reassemble the tool head. Check here and see. Oops. Just didn't want to unhook those because I don't want to get the wires backwards. I wanted to see if this was actually going to fit to make sure. So, okay. So there is just a little bit, probably a 4 or so millimeter gap. Magnets are pretty strong. So see how it kind of makes it a little crooked there. This piece doesn't fit, I feel like, super good into the mount. Not as tight as regular Klicky. But I'm going to adjust this down a little bit, which is recommended in the GitHub. But I found another issue somebody had mentioned. So these were already, when I bought, the switches were already soldered to the board, which I don't know if you can reverse them. I think you can, but it may not operate the optimal way. But to use Auto Z, you need to probe the bed, and then you need to probe this Z end stop. However, since this sticks out, the back, you have to probe the back of the body here on the stop. So you're going to hit the switch before the pin. So you would need, I guess, an extra long pin, or the other style D2F switch, I believe, may work. But currently I stopped using Auto Z because of my issues. So I'm going to stick with virtual here for a little bit, see how it goes. But that's something worth noting if you're trying to do a direct swap between the two. So those magnets are super strong. The magnet to hold it into the actual slot isn't super strong. You can kind of see how easily it gets kind of manipulated there. But I'm going to adjust this and then recheck that and see how it is. Okay, so this is about the final resting spot there to where it feels pretty good. What I did, I basically stuck it on the tool head and moved the tool head around and left just a hair gap so where this PCB was not smashing, and then snugged it down there and kind of gave it some test. But my only thing is, like, the magnet, there's only one magnet and a screw now to hold it in, which it has enough strength, I think, but the fitment is just a little bit looser than I would probably like. I don't know if it's going to matter, but I won't know until I print. Alright, we're back together. Everything's assembled. This is such a tight fit, but it's kind of back on there. Too many connectors. So that's where the tool head PCBs or CAN bus, getting rid of all this, comes in handy. So first step, we're going to go to our machine page and make sure that with the probe off, we get triggered. Now I'm going to manually grab the probe. I stick it on there. We do get a blue LED. And we get open. So since I'm configured for virtual end stop, that they are both the same right now. But now I'm gonna try to see. Try to set this so you can see it. Okay, so I'm holding the switch on the probe, refresh, we're triggered, and we're off. Light, no light, light. So that seems to be all good. So my configuration and voltage supply. So my configuration and voltage supply all seems to be good. So now what I'm going to do is I need to home this so I can move it. But I cannot print yet because my offset's going to be incorrect right now. So, yeah, you see that didn't work. So now I can move it, but actually, yeah, what I'm gonna do is grab it. I need to stick her back on there. Try to manually see if we can get it lined up so I can change those values. It's gonna be hard to show you, but you're going to want to line it up as good as you can to where it doesn't smash it off. So the way mine is, I'm set at 350 is the Y destination. I'm at 44 right now, which looks to be good. value I just had, which was 44. Yep, and then we're just gonna line it back up and see how it goes. So with Klicky PCB, it actually docks sooner. So like I'm already at 340 and it's already attached. So let's go back again. And we're gonna go full to the right. Docked pretty good. All right, we are going to go to my Klicky variables. Yeah, so this is 42. So I'm going to change that to 44. Just have a look here. And I don't think, like, and that goes into what he has here. So he changed his 2 millimeters, so I had to change mine 2 millimeters. If you're using Auto Z, you'll have to change your probe switch. But I can't use that yet because of the design, and at least with this switch. So we're gonna go back. So after that, we're just gonna make sure everything works. So we know the probe works. We're gonna want to home. Make sure it all works and docks correctly this time. Alrighty, that's all good. Then our last step is going to be do our calibrate. Because you have to manually attach the probe with my setup. So I'm going to move it to the center. We're going to run probe accuracy. Here are those results. Deviation 003, not too bad. It's not tap, but I'll take it. Okay, last step here. We are going to run the probe calibrate command. Make sure you QGL and home first, so there's not any discrepancies there. Make sure you attach the probe, since it won't do it automatically, more than likely. I like to put it to the center, run the command. It does it however many times, and then I take off the probe and put it back in the dock. Some people may say you want to do it hot, but I'm not going to. You see we get this screen, and we're just gonna go down. As we go down, it's 1 millimeter at a time till we get close, and then we start using the smaller increments. I'm down to -2 on the screen. Oh, see, I lost the movement. So now a little too tight. It pulls, but I can't push. So I'm gonna go back up, and then I'm gonna pick a smaller increment again. So I'm using the 0.05 negative. And I'm gonna use 0.01. I can feel a slight drag. I'm gonna go one more. I like a good squish, and it kind of helps with the texture. So kind of see pulls easily, but it's almost enough to make somebody always interrupts. Okay, so this is something you can redo and kind of play with, and adjust it with live Z offsets. I kind of like to set it and forget it. So I'm gonna go one more 0.05 increment right there. Then I'm going to hit accept on the screen. It came out to 9.575 is what it says. Then I'm going to run save config. And that value that it saves for that Z offset should end up saving in the bottom of your printer config. So now I have a section that says probe Z offset 9.575. I'm going to QGL. And I got some horizontal move Z, can't be less than probe Z offset. Never seen that message before. That's probably, let's see, what was the message? Horizontal move Z. So that's what we're going to do. We're going to copy that, go to printer config, Control F, and look for that. I have it under bed mesh. Oh, okay, yeah, see that? Horizontal move Z is set to 9. And my offset was like 9.5. So I'm going to set that to 10. do a save and restart. Okay, now we're doing our TGL. Oops. Yeah, so you can almost hear it. The probe is barely touching. And now I got a probe triggered. So what we're gonna do, go search for that again. We're gonna give it, we'll give it like what, 5 millimeters. So I'm gonna change it to 15. It's maybe something I have to look into later on. Yeah, we got a nice clearance. Getting pretty good numbers on the screen for this. Okay, so now that that's done, I'm going to manually move it to the center of the bed, and I'm going to pick my Z height, go 5 mil, kind of eyeball it. And then we'll go down to 1. I like to do it this way just so I hopefully don't ram the nozzle to the bed. So I'm down to 0.4 on my Z. And 0.2, which would be your normal first layer height. You can see a nice little drag, and just enough to leave it flat. It goes. It kind of wants to bunch up if you lift it. I think that's going to be pretty close to where I want it. So I'm going to go do a test print. Okay, so I forgot to actually purge the filament before I did anything. So it didn't start printing till a ways in. Probably hard to see, but yep, not nearly enough squish there. You can see it's see-through. But normally I like to test it on a 1 or 2 layer print, so I can kind of see and look for the perimeter lines to just be barely noticeable and go off of that. So I'm just gonna make sure to purge nice and good, and then probably drop it down a hair and then run the same print again until it's to my liking.